Hello everyone, today we'll be discussing the quick solutions of All India AIATS Test Series, Test 6 Mathematics paper which was held on 1st March 2020. So let's start with question number 51 which says let fx is equal to integral from 0 to x sin t upon t into dt, then incorrect statement is. And in the options we have to talk about f of 0, f of 1.1, 2.1 or 3.1. Right? So firstly, let's find f dash x because we have to talk about increasing or decreasing function. So differentiating, we get f dash x equal to sin x upon x into differentiation of x, that is 1 minus 0. So this is f dash x. Now if we talk about the interval for x belonging from 0 to pi, sin x is in first or second quadrant, that is sin x is positive and x is also positive, which means for this interval f dash x is greater than 0, which means fx is an increasing function. Now it can be seen that all the values that are given in the options are given in this interval only, right, except for 0. So we can say f of 0 is definitely 0. So this is less than f of 1.1, less than f of 2.1, is less than f of 3.1. Now we have to find the incorrect statement. So option number 1 is correct, option number 2 is also correct, and option number 4 is also correct, and option number 3 is incorrect. So our correct answer is option number 3. Next is question number 52, which says if E1 and E2 are the roots of the equation x square minus ax plus 2 equal to 0, such that E1 is the eccentricity of hyperbola from which perpendicular tangents can be drawn, and E2 is the eccentricity of that hyperbola from which no such point exists from which we can draw perpendicular tangents, right? It means that for the second one, b is greater than a, and for the first hyperbola, a is greater than b, which means that for one of the hyperbola, eccentricity is greater than root 2, and for the other one it is less than root 2, because e is equal to square root of 1 plus b square by a square, right, which means root 2 lies between E1 and E2. Now it has been given that E1 and E2 are the roots of the quadratic equation that is given, which means that f of root 2 is less than 0 because coefficient of x square is positive. So we can say 2 minus root 2a plus 2 is less than 0, that is 4 is less than root 2a, that is a is greater than 4 by root 2, or we can say a is greater than 4 into root 2 upon 2, that is a is greater than 2 root 2. So from the given options we can see option number 1 is the correct answer. Next is question number 53, which says let a, that is minus 2 comma 0, and b, that is 2 comma 0 are two fixed points, and p is a point such that pa minus pb is equal to 2, which means that locus of p is a hyperbola. Also it has been given that S be the circle x square plus y square equal to 4, then number of common tangents of locus of point P and curve S is. So let's firstly talk about the hyperbola. Right, now it has been given that A and B are the focus of the hyperbola, so 2AE is equal to distance between A and B, that is 4. Also PA minus PB, that is equal to 2A, is equal to 2, which means value of A is equal to 1, and hence value of E is equal to 2, right? Now we know that E square is equal to 1 plus B square by A square, so we can say 3 into 1 is equal to b square. So our given hyperbola is x square upon 1 minus y square upon 3 equal to 1. This is the required hyperbola, and we are given circle also, that is x square plus y square equal to 4. Now we have to find number of common tangents of both of these, right? Now tangent on hyperbola, that is y equal to mx plus minus square root of a square m square minus b square. And for circle, tangent is y equal to mx plus minus a into under root of 1 plus m square. Now, as both are representing same line, so we can say 4 multiplied with m square plus 1 is equal to m square minus 3, that is 3m square is equal to minus 3 minus 4, that is minus 7. But m square cannot be negative, which means that no such value of m exists. So we have number of common tangents as 0, so correct answer is option number 1. Next is question number 54, which says a point P moves such that the sum of the slopes of the normals drawn from it to the hyperbola xy equal to 16 is equal to the sum of ordinates of feet of normals. So we have to find the locus of point P, right? So let's say this is the coordinate axis and this is the hyperbola. Let us say we have a point P here, that is h comma k, and we draw normal from it like this. So let us say the point on the hyperbola is 4t comma 4 by t. Now slope of the normal will be t square, so equation of normal at point M can be written as y minus 4 by t is equal to t square into x minus 4t, right? Now as it is passing through the point P, that is h comma k, so it is satisfying it. So we have k minus 4 by t is equal to t square into h minus 4t. So we have kt minus 4 is equal to h t cube minus 4 t4, that is 4t4 minus h t cube plus kt minus 4 is equal to 0. Now in the question it is given that sum of the slopes of the normals, that is t1 square plus t2 square plus t3 square plus t4 square. So this is equal to the sum of ordinates of feet of the normals, that is 4 upon t1 plus 4 upon t2 plus 4 upon t3 plus 4 upon t4. So solving this, we can write it as t1 plus t2 plus t3 plus t4 whole square minus 2 times summation taking 2 at a time, that is let us say t1 t2. So this is equal to 4 taking common. In the denominator we have product of all the 4 at a time, that is minus 1, and in the numerator we have sum taking 3 at a time, so it is minus k upon 4. So minus is cancelled, 4 is cancelled. So this is further equal to sum of all the 4, that is h by 4 whole square minus 2 times sum taking 2 at a time, that is 0, is equal to k, that is h square is equal to 16k, that is x square equal to 16y is the required locus, that is a parabola. So option number 3 is the correct answer. Next is question number 55, which says the ellipse x square upon a square plus y square upon b square equal to 1, where a is greater than b, is such that it has the least area and it contains the circle x minus 1 whole square plus y square equal to 1. Then we have to find the equation of ellipse. See, for least area and it is containing the circle also, so it must be the condition of tangency, right? So let's put the value of y square, that is 1 minus x minus 1 whole square. Let's put this value of y square in the equation of ellipse. So we have b square x square plus a square into y square, that is a square minus a square into x minus 1 whole square is equal to a square b square, right? So we have coefficient of x square as b square minus a square plus 2a square x plus a square minus a square will be cancelled, minus a square b square equal to 0. Now for this one, discriminant should be equal to 0. So we have 4a4 minus 4b square minus a square into a square b square is equal to 0. Now dividing by a square, so we get a square plus b square minus a square into b square is equal to 0. That is a square plus b4 minus a square b square is equal to 0. Again, dividing by a square, we have 1 plus b4 by a square minus b square equal to 0. That is 1 is equal to b square. Taking common, 1 minus b square by a square. That is 1 is equal to b square e square, right? So value of e is equal to 1 by b. Now we need the least area. Now area is pi ab. So let's firstly find the value of a. Now as we know, e square is equal to 1 minus b square upon a square. That is 1 upon e square a square, right? That is 1 upon e square a square is equal to 1 minus e square. So a square is equal to 1 upon e square 1 minus e square, right? So area is equal to pi upon e square root of 1 minus e square into b, that is 1 by e. So this is e square. So this is the area and it should be least, which means the denominator should be maximum. Let us say f of e is equal to square of the denominator, that is e4 minus e6. So this should be maximum, which means f dash e should be equal to 0. That is 4e cube minus 6e5 should be equal to 0. That is dividing by 2e cube. So we have 2 minus 3 e square equal to 0. That is e square is equal to 2 by 3. Now we need the value of a square and b square. So we can say a square will be equal to 1 upon e square, that is 2 by 3 into 1 minus 2 by 3, that is 1 by 3. So a square is 9 by 2, and also value of b square is equal to 1 by e square, that is 3 by 2. So required equation of ellipse is x square upon 9 by 2 plus y square upon b square, that is 3 by 2 equal to 1. So multiplying by 9 we get 2x square plus 6y square equal to 9. That is option number 2 is the correct answer. Next is question number 56.